class, we already do on exercise, which is exercise on XY analysis. So in this type of question, or in this type of problems, you need to understand and you need to remember the equation. You have x and x axis and y axis equation. Okay, so I hope now everyone know how to use that equation properly. Okay, so in the books you can do other exercise regarding this SY analysis. Okay, so usually in the question or in the problems, it will be a combination of analysis, which means that from XY, and in that analysis you need to use NT analysis as well. So it's a combination. So the most important thing is you need to understand the equation on each analysis. XY, and they have their own equation, NT, and also the R theta. Okay, R theta axis. Okay, before I proceed to this example, is there any question? Ada soalan ke? Apa-apa nak tanya?
No, sir.
Okay, so if no question, so I will proceed to the example. So usually in my class, I will do the example and then I will go with the exercise. So usually in the example, is a practice of using the equation. So for this case, you need to familiar on how to use the equation. Okay, so here is as I record this one first. Right. So this is for the NT analysis, which is a normal and tangent. Okay, so particle A is taking a bend with velocity and acceleration shown. Okay, so determine the radius of curvature and the rate of change of speed. So when you have NT analysis, okay, then there will be the equation, which is V is equal to Vt is equal to let's say here is V is equal to V, which means that velocity is equal to velocity along tangent of the curvature. And then you will have AT, which is equal to dV over dt, or rate of change of velocity, or V dot. Okay, and then you have the an is V squared over rho. So this rho is actually a radius of curvature. Okay, so you need to understand what would be this radius of curvature, uh, because in the R theta analysis you have another radius. Okay, so please you make sure that you understand what would be the radius of curvature for NT analysis and the radius for R theta analysis. Okay, so here you have a V and 15 meter per second, and then acceleration 3 meter per second squared. So in this analysis, as I mentioned previously, for NT analysis, we do on the particle itself. Okay, there is no reference point for NT analysis. The axis is on the particle, okay, at the location of the particle. Okay, so this is particle A is taking a bend, okay, meaning that it's moving with a curve path. So the velocity is tangent to the curve, so means that you know this is your tangent axis. Okay, this is your tangent axis, and then you need to draw the perpendicular axis to the tangent axis, which is n axis. So N axis is 90 degree to tangent axis. Okay, so 90 degree to tangent axis, which is N. So this N always inward of the curvature. Okay, you have this curve, so N always inward to the curvature. Okay, you are given with the total acceleration here. Okay, meaning that if you want to determine AT and AN, then you can resolve this A into T and N axis. Okay, by the given angles. Okay. Okay, first we find what would be the radius of curvature. So the radius of curvature is belongs to the equation of acceleration to normal. So you are given with acceleration 3 meter per second squared. So in order to resolve this acceleration to normal, you need to use acceleration to normal 3 sine with 40 degree, 60 degree. So this is your acceleration to normal axis. Okay, acceleration along normal axis. So now you need to determine what will be the rho. So rho is equal to v squared over acceleration along normal. V squared given here is 15 squared over 3 sine 60. Then you get the rho. Please put the unit. Okay, so in this case is a meter. Okay. So then you need to determine what would be the rate of change of speed. Okay, meaning that the rate of change of speed is dv dt. Okay, rate of change of speed is dv over dt. Okay, so you know that acceleration are given with total acceleration. So the rate of change of speed is just at. Okay, so AT acceleration to tangent is equal to 3 cos 60 degree, and then you get acceleration, the rate of change of speed. So this one is for question A, this one is for question B. Okay, so rate of change of speed is just dv dt, which is along tangent. Okay, because why we say that rate of change of speed is at, because rate of change of speed is along the velocity line. Okay, along the velocity line. So that's why dv dt is acceleration to tangent. Okay, so this is the basic example for MT analysis. Okay, so then we go on example 3.6. Okay, so here a car travels along a straight road. Okay, so there is a keyword there. A car travels along a straight road. So the keyword is straight road. Okay, straight roads means rectilinear motion, which is you learn from on the previous chapter. So from A to B is a rectilinear motion. Okay, and then it's taking a bend a 20-meter radius curve at B. So from point B, the car start to move in a curvilinear motion. Okay, curvilinear motion. Alright, so determine the acceleration at B for the following situations. Okay, so where question A is velocity at A is equal to 20 meter per second, with the acceleration at A is equal to 2 meter per second squared, which is constant acceleration. And then question B is velocity at 20 meter per second, constant velocity. So means that we know acceleration here is 0, still constant acceleration. Okay, still constant, even the acceleration is 0. Okay, so now you are given the information at A. Okay, you are given the information at A, and then you need to determine the acceleration at B. Okay, so from A to B is a rectilinear motion. Okay, A to B is a rectilinear motion. So if I can recap the previous slide, which is chapter 2, okay, let me show to you what will happen. This is for belongs to the special case. Okay, this is belong to, let me share the previous slide first. Okay, from A to B is constant acceleration. So it's belong to this special case. So for this special case, uh, you have this equation. Okay, this equation. So since it's moved with a rectilinear motion, means that one axis only. Okay, when the particle move from one point to one point, so it move with one axis only. So that's why in this equation you don't have ux or uy, vy or vx. Okay, it's just a general equation because when the particle move in a straight line, so we can see that it's moved with a one axis. Okay, so from A to B, you need to use this equation. Okay, constant acceleration for question A, and question B is constant velocity. Constant velocity is still a constant acceleration. Okay, so this would be your equation. So from A to B, you need to use the equation of rectilinear motion. Okay, here is, alright, we go back to our example here. Alright, so we have a rectilinear motion. Okay, rectilinear motion from A to B. So B is where the particles start to move with a constant, to start to move in a curvilinear motion. So at B, you will have the acceleration to normal and acceleration to tangent. Okay, so at A is just a acceleration only. Okay, which is the rectilinear acceleration. Okay, so now determine the acceleration at B. Okay, so you know that at B is where the particles start to move with a curvilinear motion. So you will have tangent to the curve is tangent. This is tangent. Okay, and inward to the curve is normal. Okay, so you will have determine the acceleration at B. So you will have acceleration to tangent and you will have acceleration to normal. Okay, so first you need to determine what would be the value that you can obtain from A to B. Okay, so you have here is uh, you know the initial VA, which is 20 meter per second. Okay, which is let's say here is I put at point A is the initial, and then point B is the final position, because you have let's say you have V squared is equal to U squared plus 2A S minus S naught. Okay, so this is a final velocity, which is point B. This is initial velocity, which is at point A. So at initial you have a VA, or let's say I put here as UA because it's to avoid the confusion. So UA is equal to 20 meter per second, and then you will have acceleration at A is equal to 2 meter per second squared. Okay, so as A is equal to 0 and as B is equal to positive 50. Alright, So here, what you can do, you can substitute all the knowns parameter into this equation to get the velocity at B first. Okay. So why do you need the velocity at B? Anyone can answer? Why do you need to find velocity at B? Anyone? Why do you think that we need to find the velocity at B?
Use formula to calculate the acceleration.
Sorry, can you repeat? It's not
I
clear.
I can so we can use the formula that includes the acceleration and the radius of curvature to calculate the acceleration.
Okay. So why do we need to find the VB is because we need to use this VB for the acceleration to normal. Okay, because we want to find the acceleration to normal. Okay, that's why we need to find this final velocity, which is from point A to point B. The final velocity is at point B. So VB. So here you have VB squared equal to 20 squared plus 2. A acceleration is given time with 2. SB, this one is SB. Okay, S naught is A. So SB is 50 minus 0. Then you get VB. So VB here you get 24.5 meter per second. Okay, so now you can determine AN. So AN is equal to 25.4 squared over 20. So then you will get 30 meter per second squared. Okay, this is VB squared over rho. Okay, so now in order to determine what would be the acceleration, for point B, you need to, because acceleration here is equal to AT squared plus AN squared. So now you know your AN. So what would be your AT? Acceleration to tangent. Anyone want to try? How to determine this AT? AT is acceleration at B, along tangent.
Same as the constant acceleration A.
Yes, correct. Because from A to B, the acceleration is constant. So it follows the tangents of this axis. Okay, so straight line acceleration is constant. So which means that is along tangent at B. So AT is actually equal to acceleration to A because it's mentioned is constant. Okay, from A to B, the acceleration is constant. So we say that AT is equal to AA. So then you can determine what would be your AT, which is 2 squared plus 30 squared. So this is just the magnitude of the acceleration. So then you need to determine what would be the direction of the acceleration. Okay, so since you know that this is the axis, okay, so this is A T, this is A N, okay, so the acceleration might be somewhere here, okay, theta. So you need to determine this theta. So tangent theta is equal to AN over AT, okay. So then you can determine what would be the theta here. Okay, tangent inverse AN is just 30 over 2. So this is if you look this one, it will be like when you do the analysis of the resultant force, which means that you get the resultant force on X and then the resultant force on Y, and then you want to find what will be the total resultant. Okay, it's the same. It's based on right angle triangle rules. okay, right angle triangle rules to obtain the theta here. Okay, because we have the axis AT, the acceleration to tangent, acceleration to normal. Since this acceleration is 90 degree each other, so you need to use this equation for direction and then this equation for magnitudes. Okay, that one is for question A. And then we go on question B. So in the question B, you just notice that you can notice that there is a constant velocity. Okay, from A to B, constant velocity. So meaning that the acceleration A is equal to 0. So acceleration A is actually equal to acceleration to tangent equal to 0. Okay, so meaning that AT equal to 0. So means that you don't have AT here, no AT, you just have acceleration to normal. So acceleration is equal to square root acceleration tangent squared plus acceleration to normal squared. So since here is 0, then you get acceleration is equal to acceleration to normal. Okay, so then here is actually equal to 30 meter squared. So you have 30 meter squared. Okay,
Sir, why
alright,
30?
alright. So it's actually 20 squared over 20 because VA here is 20. Okay, acceleration constant velocity. So that's why here is 20 meter per second squared. Okay, so you need to use this velocity because from A to B the velocity is the same. VB, so I can say you can put here VA is equal to VB equal to 20. So you use this 20 to determine uh, the AN. Okay, so the direction of AN is just downwards. So this is the direction of acceleration to normal. And always remember acceleration to normal, normal axis always inward to the curvature. Okay, any question?
Sir,
Yes.
so when they mention to determine the acceleration, need to find both acceleration, right?
Yes. For the when the particle move in the curve, then you need to find both lah, acceleration to tangent and acceleration to normal. For the case of anti-axis.
Okay, sir.
Okay, any other question?
Sir,
Yes.
how do we get again the 20 square over 20 for this acceleration?
For question B.
Yes.
So it's mentioned that here VA is constant velocity. So meaning that from A to B, the velocity is the same because it's constant. Okay, so VA is equal to VB. So at acceleration to normal at point B, you will get VB squared over rho. So VB is the same as VA, so 20. 20 squared over rho, you get rho is here. So you get 20 meter per second squared. You get what I mean?
Yes, sir.
Yeah. Okay. So for question A, because we have acceleration. So since we have the acceleration, so means that the velocity at A and B should be different due to this acceleration 2 meter per second squared. Because the acceleration will increase from A to B due to this the velocity will increase due to this acceleration. Okay, 2 meter per second squared. Okay, so uh, we do on exercise 3.7. A marble is released from 13 degrees slanting angle, slanting platform. Okay, with initial velocity u is equal to 12 meter per second as shown. So calculate. Question A is the maximum height. Question B is the radius of curvature. So meaning say you may notice that for question A, maximum height is actually XY analysis. And then question B, radius of curvature. So means that is for NT analysis. Okay. And then you need to determine what would be the velocity of the marble as it hit the ground. So means that you can use XY analysis here. So it's a combination. So in the question or in the problems, in the test or exam, you will have the problems that is combination of axis. So you need to understand that. Okay. So maximum height means what? What is the information that you have for maximum height?
Velocity 0, sir.
Velocity along y is 0. Okay. Vy is equal to 0. Okay. So you need to mention this y, only y, because along x is constant. Throughout the flight, the velocity along x is constant. Okay. This means that ux is equal to vx. Okay. So here is maximum height. So you have x-axis equation and y-axis equation. So x-axis is ux is equal to vx. So initial velocity is equal to final velocity, and you have sx minus s naught x is equal to uxt. So this one is for x-axis, and then you will have y-axis, which is that you have vy is equal to uy plus I forgot the equation here. Let me check first. Okay, so vy uy plus ayt, and then vy squared is equal to uy squared plus 2ay sy minus s naught y, and then you have the last equation, sy minus s naught y is equal to uyt plus half ayt squared. So this is three equation for the y-axis. Okay, so hashmax is you have we list all the information that we have. So for the initial here is we have uy. Okay, uy is equal to 12. Uh, so this one is y. This one is x. So uy is this one is 30. So uy is u sine 30. So to 12 sine 30 meter per second, and then ux is equal to 12 cos 30 meter per second. Okay, so you have here is with s naught x is 0 with, and then s naught y is equal to 1 meter, 0 meter. So what else do you have? uh this one is for question A. Okay, this one is for question A. So final is at maximum height, max height. So final is at maximum height, which is you just have here sy is hash max. Okay, sy is hash max, and then you have at maximum height vy equal to 0. Okay, so this is the information that you have for this question A. Okay, and then you can directly use equation y-axis, okay, to determine the maximum height, because maximum height is related to height, or distance is related to displacement. So when we say about the maximum height, means that is along y. So you can you need to check either question 2 or question 3 only. So for this case, we don't have the time. Okay, on the information, no time is provided. So you just use the second equation here. Okay. So Vy squared is actually 0. So 0 squared is equal to 12 sine 30 squared plus with 2. Ay is G negative 9.81. Sy is H max. H naught Y is 1. Okay, then you get your H max. What will be your H max? So for the H max, you may notice that you get 1.835 meter. Okay, so since our reference point here is at this location, our reference point here is at this location. So when you calculate this H max, actually just this distance you get here is 1.835. Okay, so in order to get the total H max here is you need to add with 1 meter. Okay, then this what you get 2.835 meter. Okay, so usually when we calculate the height is based on our reference point. So let's say here is point A. So it's based on this the distance from this reference point A. So you need to look at the figure if the question provide the figure. So you need to understand that when you calculate, it's based on the reference point here. Okay. So since H max is from the ground, so you need to add 1 meter. Okay, this height here. Alright, so then you need to determine the radius of curvature when the marbles reach its maximum height. So means that the position of the marble is here now at the maximum height. So you need to determine the radius of curvature. So since the velocity or the motion of this marble is from this is the motion of this marble. So T is tangent to the curve. Okay, follow the direction of motion, and then you will have the 90 degree to the tangent is your normal. Okay, is your normal axis. Okay, so you have N and T. All right. So here at maximum height, you have only Vy is equal to 0. So this one is for question B. And then Vx is equal to Ux. Okay, Vx is equal to Ux. So the radius of curvature is equation come from acceleration to normal is equal to V squared over rho. Okay, V squared over rho. All right. So now V is actually your Vx or Ux. What would be your acceleration to normal? How to obtain the acceleration to normal? Anyone?
G.
Sorry, can you repeat?
G. 9.81 G.
Yes, it's correct. It's actually G. Okay, your acceleration to normal is actually G. So now you can calculate your rho. V squared is Vx. What is Ux? 12 cos 30. So 12 cos 30 squared over G. Okay, we just use for G we just use because it's follow the direction of this axis. Okay, and is actually for this case is inward. So your direction of G is downward. Here is follow this direction of N. So that's why here the G here is positive. Okay, for the X and Y axis, we know that this is your X, this is your Y. So for the case of XY axis, that's your G is negative because it's below than positive axis of Y. It's the opposite direction of Y. So that's why your AY equal to G equal to negative 9.81 because it's against the direction of Y. So for this case, your N is the positive N axis is downward. Oh, okay, is downward and this G is follow this N axis. So that's why your AN is equal to G is equal to 9.81. Okay, because it's follow the axis of the N axis. So that's why positive. Okay, and then you get your rho in meter. Okay, so then we go question C. So before we go question C, any question? Ada soalan ke?
Sir,
Yes.
for the V square, always use the Vx. The Vy is not.
Zero lah. Vy is zero because it's mentioned that maximum height here. The result for
So,
curvature when the marble reach maximum height.
so if the question is, it asks any points, like not maximum point, will
If
the
that
Vy use?
not okay. So your question is actually question C.
Okay.
Okay. Question C is the velocity of the marbles as it hit the ground. Okay, which means that the velocity not in the maximum height, which means that on the other point lah. Okay, so point C, the velocity of the marble as it hit the ground. So meaning that is somewhere somewhere here lah. Okay, somewhere here. Okay. So so here you have you need to determine you know that Vx is actually equal to Ux. So now you know velocity along X. Okay, so here you have let's say Vx, then you need to determine here Vy. Okay, Vx and Vy. So Vx and Ux you know, which is 12 cos 30 meter per second. So now you need to determine Vy. Okay, Vy. So if I can refer back to the point I have here, initial point here is, okay, let me list again. Okay, for question C, the initial is still the same. Okay, initial point is still the same, which means I have Ux equal to 12 cos 30, and then Uy is equal to 12 sin 30, and then S naught x is 0 meter, S naught y is 1 meter. Okay, so now my final location is actually at the ground lah. Ground. Okay, I can say here is ground. So now this is my final. So at the ground here, what is the information that we have at the ground? We only have SY. SY is, so this is your reference point, and the point here is below the reference point, which is 1 meter, below 1 meter. So SY is actually negative 1 meter. Okay, because SY is displacement. Displacement is a vector. So you have magnitude and direction. Okay. So this is the information that you have for the final position, which is at the ground. So if we can look at this y-axis, because we focus on Vy, so we need to use y-axis equation. Okay, so question number one, we have time on the equation. So in the parameter that we have here, no time. So definitely equation 1 and equation 3 cannot be used lah because you don't have the time. Okay, so the only equation that you have, only equation number 2. So you just use equation number 2. Vy squared is equal to uy squared plus 2ay sy minus s naught y. Okay, so this is the equation that you have. So vy is unknown, so this is the parameter that you need to determine. So uy is 12 sine 30 squared plus with 2, ay is g, negative 9.81, and then sy is negative 1 minus negative 1, sy s naught y, sorry, sy to, so here is minus 0. Okay, okay, so here is I think you need to put 0 here because this is the reference point. So at this position is below, so negative 1. So we need to find the difference. So if I put 1 here and negative 1, so sy minus s naught y will be 0. Is actually the difference is actually negative 1. Okay, so negative 1 minus 0 here. Okay, so this is the difference between the final position and the initial position. If we can look at this figure, it should be negative ones lah. Okay, because we have a reference point at initial point here and the final point here. So obviously we know here it should be negative 1. So in this part here should be negative 1 lah. Okay, so then you can get your V1. So your V1 in terms of meter per second. Okay, can someone help me calculate this one? What would be your Vy?
7.46.
7.46. Okay, so now you obtain your Vy. Okay, so so this is the direction of Vy, and then this is the direction of Vx. Okay, so I think I need to add space here. Okay, you have here is Vx, here is Vy. Okay, if I put Vx, Vy, then you need to determine your V. Okay, so Vx is 12 cos 30, and then Vy is 7.46. Alright, since V here is your velocity, then you have magnitude in terms of meter per second, and then you have your direction. Okay, so V is equal to Vx squared plus Vy squared. Okay, and then the theta is equals to tangent inverse Vy over Vx. So this is your magnitude of V and the direction of the V at the ground as it hit the ground. Okay, any question? Okay, ada soalan ke?
No.
Doctor,
Yes.
about the height just now, use since the initial height of y is 0 and the sy is negative 1, is it?
Yes.
Why is it the initial y why is it s initial y is 0?
Sorry, which question? Question C.
Yeah, this question also. Why is it s initial y is 0?
Okay. So for X, we don't have the information. So we say that we assume here X is 0. Okay, since here is your, let's say I put my axis here. So let's say here is Y, here is X. Okay, here is X axis. So this is my reference point, let's say, for example. So this marble is located along X is located at the reference point. So we say that the position for this marble along X is 0. Okay. Okay. So for your question, why sy s not y is let's say I mentioned previously s not y is 0 and sy is -1. Okay, so if we refer to this reference point here, let's say I use this reference point. Previously, I use at this position as my reference point. So now I change my reference point to at the ground now. Okay, so this is my reference point, origin or reference point. So for this case, my s not y is actually 1. My sy here is actually 0. Okay, if my reference point is here. So if I input my value into this equation, I still get 0 minus 1. I still get -1 because the final point is below the initial point. Okay, the final location is below the initial location. So that's why you get negative. Displacement should have the direction. Okay, clear?
Clear, Doctor. Thank you, Doctor.
Okay, any other question? Okay, if there is no question, I think I go on, we do on the example of R theta exists. Okay, so before we do some example exercise, so just to recap, so this is the R theta analysis. Okay, so similar to xy, R theta exists refer to a fixed point. Okay, means that you have the reference points lah. If you do on the NT, you do specifically on that particle at the particular location. Okay, so for the r theta, we have a fixed reference point. Okay, let's say at point A, you just you do the axis is at point A. So if the particle move to point B, the axis still at the point A. Okay, the axis is not changed. Okay, you need to consistent lah when you do the analysis. Okay, and then similar to NT, R theta is analyze one point at a time. Okay, it's refer to one point at a time. So okay, so in order to draw the axis, okay, in order to draw the axis, we draw the axis on the particle. But in reference to draw this R and theta, we still need reference point. Okay, after we know based on the reference point, we will draw the axis on the particle. Okay. Okay. So here R axis always outwards. Okay. R always outward. That represent the axis is positive. The direction is positive. Okay. Draw a line from origin or reference point to the particle. Okay. And then outwards is the positive R axis. Okay, for the theta axis is directed toward increasing theta. So please remember when the between two axes is perpendicular or 90 degree. Okay, so for how to determine the positive theta axis is based on the given angle. If the angle provided from x to the r, from x to the r, so the positive theta should be this direction. Okay, and if the question give the angle from y to the r direction, from the r line here, then the direction of theta is follow the direction from y to r. So this is your positive theta axis. Okay, so for the equation, you have two equations that come from velocity and acceleration. Okay, so for velocity, you have Vr plus V theta. So please remember this is a vector summation. So you need to use V equal to Vr squared plus V theta squared. So this is a vector summation. And then Vr is equal to R dot and V theta is equal to R theta dot. Okay, R dot means what? The rate of change of R. Okay, so usually in a rectilinear or in SY or in NT, so we know that V is equal to ds over dt. So this is displacement. So here now the distance here is R. So that's why rate of change of R dr over dt. Okay, so V theta is equal to R theta dot, and then for the acceleration, still the same. AR plus A theta vector summation, and then AR you have R double dot minus R theta dot squared. Okay, since R dot is rate of change of R, that means velocity, and then rate of change of R dot means acceleration. Okay, and then same goes for the theta. Acceleration to theta is equal to R double theta double dot plus 2R dot theta dot. Okay, which is the rate of change of the angle, okay, of the. So this is the equation that you need to remember for R theta analysis. Okay, so we go on the exercise 3.16 here. Okay, 3.16, which is you have here is okay. Okay, a fighter jet B fly along a curve. Okay, fly along a curve with a constant velocity of 550 km per hour. Is tracked by radar from A. Determine R dot, theta dot, R double dot, and theta double dot as observed from A. Okay, so now your reference point is A. Okay, as observed from A. Okay, so now you need to draw the axis first. So this is your R. So the axis is this R. And then the angle from X to the R line. So this is your theta. KR and theta. So 90 degree. Okay, so you are given with constant velocity is tracked by radar from A. Okay, so here is V. You have here V is equal to 550 kilometer per hour. Okay, change to, you need to change to meter per second. So for 450 over okay, kilometer per hour. So per hour 3,600. So kilometer. Here is kilometer. Then here is 1,000. Okay, so to change it, 550 times with 1,000 over, then you get your velocity in meter per second. Okay. All right. So here is determines R dot theta dot. Okay, so R dot is equal to VR. Okay, so you are given with V here. Okay, you are given with V. Okay, so now you need to play with the angle. Okay, so here is 25. Okay, so this line here is actually 45 degree. So here is 45 degree. So between R and V is actually 20 degree. So VR, this one is V. So is equal to V cos 20 degree. Then you get meter per second. Okay. And then we go on V theta dot. Okay, you need to determine theta dot. Theta dot equal to what? Theta dot V R theta dot is equal to V theta. So let me check. Okay, V theta is equal to R theta dot. Okay, so now you need to determine V theta first. So V theta is equal to you have V here. Okay, if you since we know that R 90 degree to theta, so VR is V cos 20. So V for V theta is V sin 20. Okay, since if you resolve this V, it will directed to this. This is your actually the direction of V theta. So it's against the positive direction of theta axis. So you have negative. Okay, negative. So you get in term of V theta there is radian per second. Okay, but the question asks R dot, theta dot, sorry. The question asks you is theta dot. So theta dot is equal to V theta okay, V theta is meter per second. And theta dot is equal to V theta over R. Okay, which means negative V sin 20 and the R here is 1 kilometer, 1000 meter equal to radian per second. Okay, any question? Ada soalan ke?
Doctor, I have a question. I'm quite confused. Why is it sin 20 for the V theta?
Okay. You have a V like this. V 400 meter, kilometer, 400 and 50 kilometer per hour. With the angle here is 25 degree. Okay, at this point B. Okay, so you know that this R is this line here. The distance from A to B is 45 degree. So in order to draw this R, it should be along the same line. Okay, along the same line of this distance from A to B. So the line here is, this is your R. So which is 45 degree. Okay, so from here you have since we know that theta is 90 degree to R, so you have since it's follow this direction 45, this is the direction of theta, so this is your theta. Okay, 90 degree. Okay, so now in order to resolve this V to R, you find the angle between them. Okay, the angle between V and R, which is 45 minus 20, you get 20 degree. Okay. So if I extend the line here, so this is positive R and this one is negative R. Okay. And then if I extend the line of this theta, this one is negative theta axis. This one is negative theta, this one is negative R. This one is positive theta, this one is positive R. So if you want to, you know that between the axis, the angle is 90. So the angle here is 90 degree, angle here is 90 degree, angle here is 90 degree as well. Okay, between the axis, the angle is 90 degree. Okay. So now you need to resolve this V to theta axis. Okay?
Okay, I get it. Nampak dah.
Yes.
Okay.
Any other question? Okay, then you need to determine R theta double dot. Sorry, R double dot and theta double dot. R double dot come from AR. So acceleration along R is equal to R double dot minus R theta dot squared. Okay. A theta is equal to R theta double dot plus 2R dot theta dot. Okay. So the unknown that you need to determine here is R double dot, and here is theta double dot. So first you need to determine what will be your AR and then what will be your A theta. So R dot you already obtained here. Theta dot also you already obtained here. Okay. So for this equation, you know theta dot, you know R is actually this value, and then you need to determine AR, okay, to solve R double dot. Okay. So what the information that we have here? Fighter jet B fly along a curve with a constant velocity. Okay, so the keyword here, constant velocity. Fly along the curve with constant velocity. So here is V. So V is actually tangent to the curve. So if I do on the analysis, here is actually acceleration T. Since acceleration T constant velocity, so is 0. Okay. And then inward to the curve is actually acceleration to normal. Okay, so because you don't have the information of acceleration here, okay, so how you can determine the AR and A theta? So it's based on AT and AN. Okay, so based on AT and AN, you can determine AR and A theta. Okay, so this is your let's say theta axis inward, so this is your A theta. Okay, so AT is 0. Okay, so AT is 0. So A theta, sorry, it's not A theta, it's A normal. So A normal, sebab anti-analysis. So this one is A normal. So A normal is equal to V squared over rho. Okay. So V at B is equal to what would be the velocity here in meter per second? Can someone help me calculate?
125 atau 125?
Sorry,
125.
125. Thank you. So R dot, what will be the value? R dot? V cos 20.
117.46.
117.46. And then V theta or V theta negative
Negative 0.043.
negative 0.043. And then theta dot
Theta. Theta dot is negative 0.043.
oh, theta dot is negative 0.043. Okay. So means that it's not V theta. Okay, so here is 125 squared over rho is 2000. Then you get your acceleration to normal. Okay, how much this acceleration to normal? Normal acceleration 125 squared over 2000. How much acceleration?
7.81.
7.81 meter per second squared. Alright. So now this is your AN, your AT is 0 because it's constant velocity. So if we can refer back to this axis, so this is your R, this is your theta. So what you can do here, you know that this is your R. Okay, and then you have 90 degree to the R, follow this direction of theta. This is your theta axis, 90 degree to R. So what you can do here, let's say I redraw it again. So this is your AT. Okay, this is AT 0 tangent. Let's I put here as tangent axis. Tangent. This is T, and then 25 degree, and then I have R as 90 degree to T is N. So this is N, 90 degree, and then I have T R. Okay, R. This is R, 45 degree, and then 90 degree to R is theta. Okay, so now at N here you have En equal to 7.81 meter per second squared. Okay, so the angle here is actually 20 degree. So this angle here is actually 70 degree. Okay, because N and T is 90 degree. So you know the angle here is 20. So this angle here is 70 degree. So R is equal to, we know that AT is 0. So you have only AN equal to 7.81. So A is actually equal to AT squared plus AN squared, and acceleration is actually equal to AN. Okay, so this is actually your total acceleration. So R is equal to AR is equal to acceleration cos 70 degree. And then A theta is equal to A sine 70 degree. So then you obtain your AR and A theta. So then you can substitute into this equation to get R double dot and theta double dot. So AR is equal to R double dot minus R theta dot squared. Then A theta sama equal to R theta double dot plus 2R dot theta dot. So now you know this R, you know this theta dot, and then you obtain your AR. Okay, so A theta also you know, R dot and theta dot. Then you can determine what would be your theta double dot and R double dot. Okay, any questions so far? Ada soalan ke?
Why it costs 70?
Sorry, why is cost 70?
Yes, for AR.
Okay. Okay, so the angle between N and T is 90 degree, right? N and T is 90 degree. And then the angle between R and T is 20. Okay, so the remaining angle here should be 90 minus 20, then you get 70. So this A, which is equal to AN, cos 70, you get AR. Acceleration to R axis. And then this AN sin 70, then you get acceleration to theta axis. Positive, okay, because it follows the positive direction, so here should be positive. You get it? You get what I mean?
Yes. Yeah.
Okay. Okay. So here, if you notice that from this question, it's mentioned as observed from A. So for the art, for this analysis, as I mentioned, is have the reference point. So means that point A is your reference point to draw the R and theta axis. Okay. Okay. So I leave this question for all of you to do it. Okay. So it's just a very simple question. Okay. So you just need to understand the question properly. Okay. Okay. So let's do this exercise. Okay. Okay. So motion of a torpedo is tracked from an observation post at O. So you have the reference point here at O. For the instance shown, determines R dot, theta dot, R double dot, theta double, and theta double dot from O. Okay. So the first things is you need to do R theta analysis, and then D, the N and T component of acceleration A, and the radius of curvature. Okay, radius of curvature. So first thing first, we draw the axis. Okay, we draw the axis of R. So we know that R always outward from the point. So this is R. R. And since we know that the direction of theta is here, so positive theta. Okay, positive theta. So 90 degree. Okay. Alright, so here is given V. So V is equal to time with 1000 over okay, what here is 100. Okay. So then you need to determine R dot. R dot is equal to dr. Okay, so given with V, okay, let me draw this again. So this is your R, this is theta, and then you have the direction of V. The direction of V is here, V, and then here is 20 degree. Okay, and given the angle here, if I draw here is 60 degree. Okay, so here is 60, so here should be 30 degree. Okay, because horizontal and vertical is a 90 degree, so here is 60 given 30. Okay, so now you have the angle between V and R, so then you can determine 100 cos 50 positive, because it's follow the positive direction of R. Okay, and then you have V R theta dot is equal to V theta. Okay, so V theta here is actually V sine equal to V sine 50. Okay, so your R is 1000, so theta dot is equal to 100 sine 50. R is 1000. Then you get your theta dot, radian per second. This one is meter per second. Okay, so this V theta is positive because it follow this direction of theta. Okay, theta axis. Okay, then we go on theta double dot and R double dot. Alright, so what is the information that we have here? Okay, given with this acceleration, okay, total acceleration, so this acceleration is actually downwards. Okay, this is your A. Okay, 2 meter per second squared. Okay, so if I extend here, I get here is actually negative R. So negative R exists. So if you notice here, I need to resolve this A to theta, this A to negative R, to R exists, negative R exists. So here is positive theta exists. So you need to determine the angle here. So what would be the angle here? So the angle, so here is 30, 20, here is 40. Okay, this is 90 degree. Okay, and then 20 for here should be 30 degree. Okay, so A theta is equal to A cos 30 degree, and then A R is equal to negative A sine 30 degree. Okay, so then you substitute the equation, AR, this one, AR AR is equal to R double dot minus R theta dot squared to get R double dot. And then A theta is equal to R double dot plus with 2R dot theta dot. Okay, to get a theta double dot. So you know this is based on VR. This one is you already calculated in velocity analysis. So you have all the parameter, and then you can get this R double dot and theta double dot. Okay, any questions so far? Okay, here, okay. It is negative, eh? AR is negative. Okay, any questions so far? Ada soalan tak? Okay, so we go on question B. So question B is the anti-component of acceleration A and the radius of curvature. Okay, since what we can, the question should provide the curvature actually. So, but then we know this is V. We know this is V, so tangent to the curve is the curve should be looks like this lah. Okay, so this is the curve. Okay, so we know that this is your V, and then you 20 degree to V, 20 degree. Okay, so you know that tangent is in a direction of velocity. So this is your tangent axis. Okay, this one is your tangent axis. And then since the curve looks like this, so this is your normal axis. Okay, and then in between N and T, you have the given with the acceleration. A is equal to 2 meter per second squared. Okay, so you need to determine this angle. What would be that angle? Is actually 70. Okay, 70 degree. So acceleration to tangent is equal to 2 cos 70 positive, because this is the positive direction of tangent, and then relation to normal is 2 sine 70. Okay, and then you need to determine the radius of curvature. So radius of curvature is actually AN is equal to V squared over rho. So rho is equal to V squared over AN. So V squared is this value 100 squared over AN. Okay, then you can solve for question B. Okay, any questions so far? Ada soalan tak? Okay, so if there is no question, I think I will end the class till this slide. So actually, we already done on this chapter. We just do the exercise. Okay, so you can try all the other exercise. So maybe on the next class, I will do this last exercise. Okay. Okay. So any question?
Doctor, can I scan the attendance?
Okay, so okay, I think that's all for today. For those who don't have any question, so thank you very much and assalamualaikum.
Salam, thank you, sir.